Welcome to the next session of subject Engineering Maths, Chapter 2, Differential Equations. We were in the discussion of solving higher order differential equations. In particular, they are called homogeneous linear differential equations with constant coefficients. So we discussed few cases if the roots are complex and repeated, and then we discussed classroom workbook of solving previous gate questions on higher order homogeneous linear equations with constant coefficients, right? See, suppose we have complex roots like this. Suppose alpha plus I beta, m2 equal to alpha plus I beta. So if m1 comma m2 are complex roots which are repeated, alpha plus I beta and even alpha plus I beta, then its complex conjugate becomes a root of the auxiliary equation. So m3 equal to this, then m4 also equal to alpha minus I beta. So if the roots are complex and repeated, two complex roots are repeated, then their conjugates repeat twice. In that case, YC becomes like this. Assume that we are working with n equal to 4. That means fourth order homogeneous linear equations with the constant coefficients. Suppose if the roots are like this, m1 is complex root, m2 is complex root, repeated same, and in that case m3 will be alpha minus I beta and this is alpha minus I beta. That means a complex root alpha plus I beta is repeated twice. In the similar way, its conjugate repeats twice. In that case, my roots are alpha plus beta, alpha plus I beta, and alpha minus I beta repeats again twice. In that case, my complementary solution YC will be like this. This is e power alpha x into C1 plus C2 x into cos beta x plus C3 plus C4 x into sin beta x. So this is YC in case of repeated complex roots. Here we are working with n equal to 4. So that means complex roots are repeated twice. So if it repeats twice, their conjugate repeats twice. In that case, my YC will be like this. This is one possible case, because in all the cases the real part is same. What is the real part? Alpha, and imaginary part is beta. As we have seen in the last session, when the roots are complex roots, two functions will be involved in case of YC. One is exponential function, another functions are trigonometric functions sine and cos. So here when you observe this, so multiples of x occurs. Multiple of x occurs. So multiple of x occurs whenever there is a repetition of roots. This is one possible case. Another possible case is, suppose I am working with n equal to 3. Third order homogeneous linear equations with constant coefficients. Suppose if m1 equal to alpha plus I beta, m2 equal to alpha minus I beta. So definitely, since we are working with third order equation, if two roots are complex numbers, then next root must be real number only. Because a third degree polynomial cannot have three complex roots. When you take a third degree polynomial expression, at most it will have two complex roots. So if one is alpha plus I beta, another is alpha minus I beta, so ultimately third root must be a real number alpha. In that case, what will be structure of YC? So in that case, my YC will be, at first I am going to write YC for complex roots alpha plus I beta, alpha minus I beta. In that case, this will be e power alpha x into C1 cos beta x plus C2 sin beta x, plus this is a real root, so plus C3 into e power m3 x. Right? So hope you understand these points. Write these as notes. Note: if n equal to 4, and m1 equal to alpha plus I beta, comma m2 equal to alpha plus I beta, comma m3 equal to alpha minus I beta, and m4 equal to alpha minus I beta, then YC will be this. If n equal to 4, m1 equal to alpha plus I beta, m2 equal to alpha plus I beta, m3 equal to alpha minus I beta, and m4 equal to alpha minus I beta, then YC equal to this equation. Note this equation. e power alpha x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. One more note. If n equal to 3, gamma m1 equal to alpha plus I beta, comma m2 equal to alpha minus I beta, and a real root m3. If n equal to 3, comma m equal to alpha plus I beta, m2 equal to alpha minus I beta, and a real root m3, then yc equal to this, e power alpha x into c1 cos beta x plus c2 sin beta x plus c3 into e power m3x. Right? Now we discuss classroom workbook, that is questions based on homogeneous linear equations with a constant coefficients. So let us discuss classroom workbook. Just go through classroom workbook. Let us start the classroom workbook from question number 32 onwards. Question number 32. What it is? If y equal to f of x is a solution of d square y by dx square equal to 0 with the boundary conditions y equal to 5 at x equal to 0. This is the first boundary condition, and second boundary condition is dy by dx equal to 2 at x equal to 10. Then we need to find f of 15. So we need to find the value of f of 15. So when you look at this, it is a second order homogeneous equation. So right side is 0, order is 2, it's a second order homogeneous equation with the constant coefficients. Now when you solve this for general solution, it contains two constants, say for example C1 and C2. Now in order to solve these two constants, two boundary conditions are given. So what is our task? At first, let us try to find the general solution of this equation. Its general solution will be y equal to yc. Now find the general solution as per required cases and then apply two boundary conditions. You will get C1 and C2 and then replace x by 15, right? So in this case, let us try to solve this equation. This equation is in the form d square y equal to 0. So what is my auxiliary equation? The auxiliary equation is f of m equal to 0. So therefore f of m is nothing but the function before y. So therefore this implies m square equal to 0. Implies two roots are there, one root is 0 and another root is 0. So both the roots are real and equal. Therefore y equal to c1 plus c2x into e power 0x. Roots are real and equal. So y equal to c1 plus c2 into c2x into e power 0x. Therefore y equal to c1 plus c2x. This is my y. Now let us apply boundary conditions. What is my general solution? C1 plus c2x. So the first boundary condition is this: y value 5 when x equal to 1. Replace y value 5 when x equal to 0, then c1 becomes 5. Now therefore y equal to 5 plus c2x. I have replaced c1 by the constant 5. Second boundary condition is this. So here dy by dx equal to, this is c2. Here dy by dx is 2 when x is 10, but no x on the RHS. Therefore dy by dx is 2. That is c2 value is 2. I have applied second boundary condition to get c2. When I apply first boundary condition, I am getting c1 equal to 5. Therefore the function y equal to c1 plus c2x. This is solution. But what is my c1? This is 5 and c2 is 2. But basically this is f of x. Therefore, f of x equal to 5 plus 2x. So we need to find f of 15. So replace x by 15, we get 35. So this is the required answer, right? Note this. So is this clear? Right. Next, we move to question number 33. So what it is, a solution of a differential equation d square x by dt square equal to minus 9x with some initial conditions. So this is almost similar to previous question, but here options are given as particular solutions. So the equation is d square x by dt square equal to minus 9x with initial conditions x of 0 equal to 1 and dx by dt equal to 1 x equal at t equal to 0 at t equal to 0. So we need to find the solution of this equation under these conditions. Look at the options. So the options are particular solutions. Now as we have seen when we gone through first order differential equations, when particular solutions are given, you need not solve the question. Just verify options using boundary conditions. If at least if exactly one option satisfies all boundary conditions, that could be right answer. But if an option satisfies all boundary conditions, it may or may not be right answer. But if an option fails to satisfy at least one boundary condition, that could be wrong option, right? Just try to understand the points. When we gone through first order differential equations, when we gone through particular solutions, we have gone through verification of options. So option A, let us try to verify boundary condition for option A. If option A satisfies given boundary condition, it may be right answer, may not be. So don't confirm and don't eliminate. The same case with B also. Suppose if option C fails any one of the boundary conditions, that can be eliminated. The same case with D also. So unfortunately, in some occasions, all options may satisfy all boundary conditions. In that case, you need to solve the problem completely, right? Similar to like this, we can proceed here also. Look at the options. The first option is t square plus t plus 1. Second option is cos 3t plus t. Third option, sin 3t plus 1 by 2 cos 3t plus 2 by 3. And fourth option is 1 by 3 sin 3t plus cos 3t. Now let us verify boundary conditions. So here x is in the numerator, t is in the denominator. That means x is a dependent variable and t is an independent variable. What is the first boundary condition? X of 0 is 1. That means when t equal to 0 implies x values are 1. Here dx by dt equal to 1 when t equal to 0. Dx by dt equal to 1 when t equal to 0. Therefore, let us see. Here all these are x values. All these are x values. Now when you replace t by 0, you will get 1. So first boundary condition is clear. If you find its derivative, the derivative of this function is 2t plus 1. When you replace t by 0, we are getting 1. Therefore, it satisfies both boundary conditions. It may be right answer, may not be. So hold this answer. It satisfies both boundary conditions. When t is 0, x is 1. When you find the differentiation, it is 2t plus 1. When t is replaced by 0, we are getting 1. So it satisfies both boundary conditions. So don't confirm and don't eliminate. Look at this option. Here replace t by 0, you will get 1. Try to find the derivative of this function. The derivative of this function is minus 3 sin 3t plus 1. Here also when you replace t by 0, the answer is 1. So second option also satisfies both boundary conditions, right? Now look at the option C. When you replace t by 0, this is 1 by 2 plus 2 by 3. When you replace t by 0, we get 1 by 2 plus 2 by 3, but this is not equal to 1. Therefore, what happened in case of option C is, it fails the first boundary condition x of 0 equal to 1. It fails The first boundary condition x of 0 equal to 1, so eliminate this. You need not go for verification of second boundary condition because it is failed. Now look at this. Suppose when t is 0, it is giving 1. So it satisfies first boundary condition. Try to find the derivative of this. The derivative of this is cos 3t minus 3 sin 3t. Its derivative. When you replace t by 0, we are getting 1. So it satisfies both boundary conditions. So the unfortunate thing in this case is 3 different options satisfies all boundary conditions. Option A, option B, as well as option D. But just by using boundary conditions, I can eliminate only option C. Now let us try to solve this equation original way. Now this is a d square x by dt square equal to minus 9x. So therefore this is d square plus 9 of x equal to 0. So what is my auxiliary equation? M square plus 9 is 0. So what are the roots? So roots are plus or minus 3i. That means one root is, so m1 equal to 0 plus 3i. Another root is m2 equal to 0 minus 3i. Roots are real and roots are complex roots. So this is alpha, this is beta. Alpha is 0 and beta is 3. So when you have complex roots, the answer will be in terms of exponential functions along with the trigonometric functions sine and cos. Therefore, the value of y equal to, actually here it is x because we need to find x value in terms of t. Therefore, this is x equal to e power alpha t into c1 cos beta t plus c2 sin beta t. So here alpha is 0, beta is 3. So for this is c1 cos 3t plus c2 sin 3t. This is my general solution. Now it is very flexible to eliminate remaining options. In this case, we don't have trigonometric functions. So extra we have t square t1. There we got c1 cos 3t plus c2 sin 3t. Even if you apply boundary conditions, suppose if c1 is 0, suppose if c2 is 0, then trigonometric functions will be eliminated. But how you will get this t square terms? So it is absolutely wrong answer. Now look at option B. Here c1 cos 3t. Now suppose if c1 is 1, it is cos 3t. If c2 is 0, sin 3t will be eliminated. But how we get t extra? So it is wrong option. Therefore A is eliminated, B is eliminated by the general solution, and C is eliminated by using first boundary condition. So answer is D. You need not find the constants C1 and C2 also. Right? Note this. Now let us move to question number 34. What is the general solution of d square y by dx square plus y equals 0 with the two initial conditions? So even in question number 34 also, the particular solutions are given directly. So let us try to verify boundary conditions even in this case also. So let me write out. What is the equation? It is actually question number 34. The equation is d square y by dx square plus y equal to 0. What are boundary conditions? Y of 0 equal to 5 and y dash of 0 equal to 10. So particular solutions are given. In option A, actually it is y equal to 5 plus 10 sin x. So when you replace x by 0, we are getting 5. Now let us find the derivative of this. So here y dash equal to 10 cos x. Even when you replace x by 0, we are getting 10. So the first option satisfies both boundary conditions. No use, we can't eliminate, we can't confirm. So come to option B. This is y equal to 5 cos x minus 5 sin x. Now you can see when you replace x by 0, we are getting 5. But when you find the derivative of this, the derivative of this is minus 5 sin x minus 5 cos x. But in this case, y dash of 0, this is minus 5. So it fails the second boundary condition. It is not equal to 10. So the second option does not satisfy the second boundary condition. So option B is wrong. Now come to option C. It is y equal to 5 cos x plus 10x. Now replace x by 0, you will get y value 5. Now let us find the derivative of this. In this case, the derivative is minus 5 sin x plus 10. Now when you replace x by 0, we are getting second boundary condition. So therefore option C also satisfies both boundary conditions. So don't eliminate and don't confirm this. Now come to option D. This is y equal to 5 cos x plus 10 sin x. Now in this case, when you replace x by 0, we are getting 5. Here the derivative of this option is y equal to minus 5 sin x plus 10 cos x. So in this case, when you replace x by 0, we are getting y dash value as 10. So even option D also satisfies both boundary conditions. Just by using options, I can eliminate only option B. Only option B, right? Now what we do is, let us try to find the general solution of this equation. Now this is in capital D form, d square plus 1 of y equal to 0. Here d is nothing but differential operator with respect to x. So what is my auxiliary equation? M square plus 1 is 0. So this implies m equal to plus or minus I. So therefore it is in the form 0 plus or minus 1 into I. This is alpha value and this is beta. Roots are complex roots. Therefore y value equal to e power alpha x into c1 cos beta x plus c2 sin beta x. So replace alpha by 0 and here beta is 1. So we get c1 cos x plus c2 sin x. Now when you look at option, for example option number this, see in this case we have extra this 5, but answer must be in the form c1 cos x plus c2 sin x. Suppose if c1 is 0, then cos x term will not be there. Suppose if c2 is 10, I will get 10. But how you will get this 5 extra? So it is a wrong option. Now even in case of this also, c1 cos x plus c2 sin x. But how to get this single term x? So it is a wrong option. Therefore option D is right answer. Okay, note this. Even this can be solved in different way. See, you can proceed directly to the general solution. So the solution will be constant into cos x plus constant into sin x. So in that case, you won't get this value extra and this x will not come extra. So just by looking at the general solution directly, even you can solve it directly also without verification of options. Verification you can do later also. But actually what we are expecting is, if only one option satisfies all boundary conditions, that could be right answer. So we were expecting this, but that may not be true in all possible cases. Options, they will say as per given conditions like this, at least 2 to 3 options or at least 2 options may satisfy all boundary conditions. So in that case, but if you are so lucky only one option satisfies all boundary conditions, then you can opt it that option. Otherwise you can proceed to directly general solution. In case of general solution, this is constant into cos x plus constant into sin x. Now this 5 will not come, so it's a wrong option. This x will not come, it's a wrong option. It's a wrong option. Now answer can be either B or D. Now when you try to verify boundary conditions, it fails the second boundary condition. Therefore eliminate this. Therefore D is right answer. Right? Next we move to question number 35. the particular solution of d square y by dx square plus 12 dy by dx plus 36y equal to 0 with y of 0 equal to 3 and y dash of 0 equal to minus 36 is. So again this question is similar to previous model. It's a second order equation. Two boundary conditions are given. Two boundary conditions are given. Now let us see how to handle this. Now in the first actually y of 0 is 3. When you replace x by 0, first option is giving 3, second option is giving 3, third option is giving 3, even last option is giving 3. Therefore, no use by using just boundary conditions. All options are satisfying the first boundary condition y of 0 equal to 3. But when you try to apply second boundary condition, the problem in this case is you need to find derivative. So actually you need to find derivative using product rule, because in each option the answer is a product of two functions. So you need to apply product rule. Instead of doing that, you can solve it directly. But one interesting point is that 3 is common in all options. E power minus 6x is common in all options. Only constant multiple of x is different. Therefore, when you look at this, the general solution will be like this. So directly I can write 3 plus c2x into e power minus 6x. Even I can write directly c1 value 3, because in all options c1 is 3. But c2 in first option it is minus 8, 25, it is 20, it is minus 12 in 4 different options. So let us try to find c2 value by using second boundary condition. The second boundary condition is y dash of 0 equal to minus 36. Now apply y dash derivative. Let us apply product rule. So this is 3 plus c2x into derivative of this minus 6 into e power minus 6x plus e power minus 6x into derivative of this, it is c2. Now y dash of 0 is minus 36. That means when x is 0, y dash is minus 36. Replace these values in this case. So minus 36 equal to x value 0. So minus 18 plus c2. Therefore c2 equal to this is minus 18. So therefore only in option A we have c2 minus 18. So option A is right answer. Now let us move to question number 36. Consider an equation d square y by dx square minus y equal to 0 with two initial conditions. What is my equation? D square y by dx square minus y equal to 0. With the two initial conditions, they are y of 0 equal to 1 and y dash of 0 equal to 3. Then we need to find y value when x equal to 2. That means y of 2 is required. So it's a blank question. Particular solutions are not given. So what we need to do is find general solution at first and then apply two boundary conditions. You will get two constants c1 and c2 and then replace x by 2. Right? Now let us solve this question. In capital D notation, this equation is equivalent to d square minus 1 of y equal to 0. The auxiliary equation is m square minus 1 is 0. Implies one root is 1, another root is minus 1. So roots are real numbers and distinct. Therefore, the value of y equal to c1 into e power m1x plus c2 into e power m2x. This is my general solution. The first boundary condition is y of 0 is 1. That means when x equal to 0, y value is 1. So replace y value 1, x is 0. So c1 plus c2 equal to 1. We call it as equation 1. What is my second boundary condition? Y dash of 0 is 3. So find the derivative of this. The derivative of this function is c1 e power x minus c2 into e power minus x. So y dash is 3 when x is 0. So c1 minus c2 equal to 3. Now the first equation is c1 plus c2 equal to 1. The second equation is C1 minus C2 equal to 3. Let us add these two equations. We get 2C1 equal to 4. So C1 equal to 2. When C1 equal to 2, this C2 must be minus 1. Therefore, I got the values of C1 and C2. Therefore, y equal to C1 is 2. So it is 2 e power x plus C2 means minus 1. So it is minus e power minus x. But we need to find y of 2. So y of 2 is replace x by 2. 2 e square minus e power minus 2. So you simplify this value. Here e is nothing but Euler's constant. This is 2.71. So when a numerals or questions are given, you need to simplify. You need to write answer value up to 2 or 3 decimal places as per the given question, right? Now let us discuss question number 37. If the complementary solution of y double dash minus y dash minus 6y equal to 0 is a into e power alpha x plus b into e power beta x, then what is alpha square into beta square? We need to find out this value. Options are given. Everything is because alpha square into beta square means it is a perfect square, alpha beta whole square. So this is a perfect square. But unfortunately, all options are perfect square. 4 is a perfect square. 16 is a perfect square. 64 is a perfect square. 36 is a perfect square. If suppose if three options are not perfect square, ultimately the next option will be right answer, right? But here, unfortunately, all options are perfect square. So let us handle this. Now we need to find the complementary solution of this. That means we need to find out yc value. So actually in capital D form, this is d square minus d minus 6 of y equal to 0. Here y double dash is nothing but d square y by dx square, and y dash equal to dy by dx. So this is my equation in capital D form. Here capital D is nothing but d by dx. The auxiliary equation is m square minus m minus 6 equal to 0. So the factorization is m minus 3 into m plus 2 equal to 0. So this implies one root is 3. So another is minus 2. See, actually these are nothing but, this is nothing but m1 value and this is nothing but m2 value, or this can be m2 or this can be m1. So therefore I can take alpha equal to, for example, 3, beta equal to minus 2. Therefore alpha square into beta square equal to 3 square into minus 2 whole square. So 9 4 ja, this is 36. So therefore in this case alpha square beta square is 36. So option D is right answer. Option D is right answer. Note this. Next question. Question number 38. Let y of x be a solution of d square y by dx square minus 4 dy by dx plus 4y equal to 0 with initial conditions y of 0 equal to 0, comma y dash of 0 equal to 1, y of 0 0, y dash of 0 equal to 1, then we need to find y of 1. It's a numeral question. Now let us solve this question. Here in capital D form, this is d square minus 4d plus 4 of y equal to 0. So what is my auxiliary equation? M square minus 4m plus 4 equal to 0. So therefore its factorization is m minus 2 whole square. This is nothing but m minus 2 whole square. So the roots are 2 and 2. 2 is a root which is repeated twice. So therefore roots are real and equal. Real and equal. Therefore y equal to c1 plus c2x into e power 2x. This is my general solution. C1 plus c2x into e power 2x. Let us try to apply first boundary condition. The first boundary condition is when x is 0, y is 0. So replace y value is 0, x value is 0, you will get c1 equal to 0. Therefore, the solution is y equal to, when c1 is 0, this becomes c2x into e power 2x. To apply second boundary condition, we need to find derivative. So y dash equal to c2 into apply product rule, x into derivative of this 2 into e power 2x plus e power 2x into derivative of x with respect x is 1. So y dash of 0 is 1. That means when x is 0, y dash equal to 1. So y dash value 1 when x is 0. Therefore this is c2 into 1. So c2 value is 1. Therefore y value is, replace c2 by 1. In this case, so it is x into e power 2x. Therefore y of 1 equal to 1 into e square. This is e square. So e is nothing but 2.71 whole square. If you simplify this, you get some value. So therefore the final answer is 2.71 whole square, right? Next question number 39. Consider an equation d square y by dx square plus 16y equal to 0 with y dash of 0 equal to 1, comma y dash of pi by 2 equal to minus 1. Has option A, no solution, exactly 2 solutions, exactly 1 solution, infinitely many solutions. Earlier we have solved one question in first order first degree differential equations. See, whenever you have this kind of options, what you need to do is you need to find the values of general constants. If each constant takes single value, then it has one solution. Otherwise, it depends on number of values. You can say that it has exactly 2 solutions or infinitely many solutions. If a constant is not taking any value, then no solution, right? So therefore, what we need to do is, first of all, let us find the general solution of this equation. This is d square plus 16 of y equal to 0. My auxiliary equation is m square plus 16 is 0. So this implies m equal to 0 plus or minus 4i. So roots are complex roots, alpha plus beta I. Therefore y equal to e power alpha x. E power 0x is 1. So this is c1 cos 4x plus c2 sin 4x. The first boundary condition is y dash of 0 equal to 1. Now let us find the derivative of this. The derivative of this is minus 4c1 into sin 4x plus 4c2 into cos 4x. So what is the first boundary condition? When x is 0 implies y dash equal to 1. Let us apply this. Y dash value is 1 when x is 0. Sin 0 is 0, cos 0 is 1. Therefore 1 equal to 4c2. So this implies C2 equal to 1 by 4. So we got single value for C2. But don't confirm that it has exactly one solution, because answer depends on the value, the number of values of C1 also, right? So let us apply second boundary condition to get the confirmation about number of values of C1. Now here y dash is, actually what is the second boundary condition? When x equal to pi by 2 implies y dash equal to minus 1. Now replace y dash by minus 1 when x equal to pi by 2. Therefore this is minus 4c1 into sine 2 pi plus 4c2 into cos 2 pi. Cos 2 pi. Right. Now in this case already we got the value of C2, but here sine 2 pi is 0. Therefore minus 1 equal to minus 4c1 into 0. Actually C2 is 4c2 is 1. This is cos 2 pi. Cos 2 pi is 1. Cos 2 pi is 1. Therefore in this case what we are getting is minus 1 equal to 4c1 into 0 plus 1. Let us verify. Let us go for simplification. See here y dash is minus 4c1 sin 4x plus 4c2 cos 4x. When x is 0, y dash is 1. That means to replace x by 0. So y dash by 1. This becomes 0. Therefore for C2 we are getting single value for C2. This is right. Now let us go for second condition. Y dash is equal to minus 1 when x equal to pi by 2. Therefore when x is pi by 2, this becomes sine 2 pi. This becomes cos 2 pi. But here sine 2 pi is 0 and cos 2 pi is 1. Therefore in this case I am getting 4c2. So anyhow 4c1 into 0 plus 4c2. So here 4c2 equal to minus 1. So here C2 is taking multiple values. One value of C2 is 4, another value of C2 is minus 4. C2 is taking two values. But don't think that it has two solutions, because C1 can be any value. Because anything into constant, any constant into 0 is 0. Anyhow this will be 0. So minus 1 equal to 4c2. I am getting C2 equal to minus 1 by 4. When you apply first boundary condition, we are getting single value for C2. So you may feel that since C2 is taking two different values, this differential equation with this particular boundary conditions have exactly two solutions. No, certainly it's not a right answer, because we got two different values for C2, but C1 can be any number, because minus 1 equal to anything into 0 plus 4c2. This C1 can be anything, because it is multiplying with 0. Anything into 0 is 0. Therefore this C1 can be any number. So in this case C1 can be any real number. Any real number. But C2 values are, one value is 1 by 4, another value is minus 1 by 4. So therefore the combination of C1 comma C2 values I can write as ordered pairs. C1 value any real number k, and C2 is 1 by 4. Just even with this also, or k comma minus 1 by 4. Now k is any arbitrary real number. Therefore it has infinitely many solutions, because C1 is taking infinitely many possible values. So when you are handling questions like this, be careful, be cautious about finding C1 and C2, right? Is this clear? Not this point. Now let us move to question number 40. I think previous question is very clear, right? So let us move to question number 40. The solution of d square y by dt square plus 2 dy by dt plus y equal to 0 with initial conditions y of 0 equal to y dash of 0 equal to 1 is. Four options are given. Now when you look at options, In option A, here actually y is a dependent variable and t is an independent variable. Now when you look at the option A is 2 minus t into e power t. So what is first boundary condition? Y of 0 is 1. So here y of 0 equal to 1. That means when t equal to 0, y value is 1. When you replace t by 0, we are not getting 1 value, we are getting 2. So it's a wrong option. But when you look at option B, even it is giving 2 plus t into e power minus t. Here also when you replace t by 0, we are not getting 1. We are getting 2 at this case. So it's a wrong option. Look at option C. This is 1 minus 2t into e power 2t. E power t. So replace t by 0, we are getting 1. So it satisfies first boundary condition. But to apply second boundary condition, derivative is required. So instead of finding derivative, I go for option D. Now it is 1 plus 2t into e power minus t. Now even here also when you replace t by 0, we are getting 1. Now but by using first boundary condition, I can eliminate option A and option B. Because first option is giving y value 2 when t is 0. Second option is giving y value 2 when t is 0. But y value must be 1. Y value must be 1 when t equal to 0. Options A and B are giving values 2 when t is 0. So I can eliminate A and B. But options C and D are giving 1 value when t is 0. Now let us handle this. This is actually in capital D form, or I can write auxiliary equation. So in capital D form, this is d square plus 1 of y equal to 0. The auxiliary equation is m square plus 2m plus 1 is 0. So this implies m plus 1 whole square equal to 0. So roots are minus 1, minus 1. Here the value of root is plus 1, but it is minus 1, so wrong option. So option D is right answer. Option D is right answer. Just by going through first boundary condition, I have eliminated first two options, option A and B. But option C and option D are giving same value 1 when t is 0. So to get confirmation, here root is 1, here root is minus 1. So when I gone through auxiliary equation, by finding its roots, I am getting minus 1. Therefore, here minus 1, here plus 1. So I can eliminate C. So option D is right answer. Note this. This is the end of the session. Thank you so much.